Alright, so picking up where the part 1 left off, we're on number 17. If you don't have these ones done yet, make sure you spend some time doing them before you watch the video. And if you haven't watched the video for the first 16, make sure you watch that one as well. So, an investment of $1,000 is compounded monthly at a rate of 2.5%. Make a graph that models the change of the investment over time. So, in order to do this, we need to use a formula for investment, okay? And it looks like, not like that. It looks like this. The amount equals the principal times 1 plus the rate over how many times it's compounded in a year times the time you put it in there multiplied by the times it's compounded in a year. Okay? And I take that back, they just have it times the time. Okay? So, the principal is how much you put in, so that'd be 1,000. Okay? Times 1 plus the rate over n. The rate, 2.5%, would be 0.025. So 1 plus 0.025 over compounded monthly, there's 12 months in a year. And then the time, that's what we're trying to fix. That would actually be x, because we want to graph this, okay? That would give us our investment in dollars value. Okay, so we can simplify this. So 0.025 divided by 12 would give us 0.002083333 repeated. Okay, then we could add that to 1, so that would just be 1.00208. We could probably just 3 round it right there, times 1,000 to the x would equal our equation. Okay? So in other words, this is this same format as y equals a times b to the x. Our a, our starting point, is 1,000. So we go up to 1,000. We draw a starting point. Now it's growing at a rate of 1.002. That's basically 100.2%, right? So we would take 1,000, and a table would probably be a good idea here. Okay, to create a table, we start out at 1,000. After the first, the second, the third, where do we go? So 1,000, we're timesing by, let's round it even further to 1.002. Okay, that would be 1,002. Do it again. That would get us to 1004.004. Do it again, 1006.012. Okay, so according to this, with these years, this is going to grow really slow. So we may want to change these to like 20 years, 30 years, 40 years, 50 years. So then we would, change our table, right? Let me erase some stuff to give us some room. Okay, so our table, maybe we want to count by 10. 0, 10, 20, 30, 40, and 50. Okay, we started out at 1,000. Because we were growing so slow, so then we need to use our equation. We'd go 1,000 times 1.002 to the 10th. Okay? That would give us 1,020.18. Okay? Then if we use that same equation and do it for 20, so replace 10 with 20, that would give us 10,040.77. Then we do the same thing from 30, for 40, and for 50. So at 30, if we change that to 30, it would be 10,081. Looking right ahead. 61.77. Then 1,083.20, and then 1,105.6. Okay, so as we would graph this, it would be going really slowly, right? It would take till 30 years to get about a little above halfway. So right about there. Okay, these would be further down. 40 would take us up a little higher. At 50, that would put us up right there. So you can see that it's starting to curve slightly. Okay, and we just keep trying to grow and grow and grow and grow and grow. Alright, so kind of a weird one, tough one. But there we go. Now, the rest of these, I don't know why it did this, but it didn't show me that its numbering seems weird. I don't know why it's off like this. Okay, but essentially, this would be 18, 19, right? Let me double check. 18, 19, 20, 21, 22, 23. I don't know what happened to my numbers. 24, 25, 26. And apparently I decided to make these both 26. That should be 27 and 28. Okay? Alright. Anyway, back onto these ones. So, the formula for calculating a person's body mass index is B equals W over H squared, for which W represents weight in kilograms and H represents height in meters. Solve for W. So we've got B equals W over H squared. We want to get W by itself. Well, what's happening to W? It's being divided by H squared, so times by H squared on both sides. Now, do we know what H squared times B is? No, so we just leave it B times H squared, and that's going to equal W. Alright, looking at number 19. Okay, the formula for calculating simple interest is I equals, that's interest equals the principal times the rate times the time. We want to solve it for R. So R is being multiplied by T and by P. So what we can do is just divide both sides by P and T. So those will cancel, becoming 1. So we get I over PT equals R. Okay, now it's going to get a little trickier here as we keep going down at 20. So we've got a volume of a cylinder. V equals pi R squared times H. Solve for H. So it's H times R squared times pi. So we just simply divide by pi R squared. So we get volume over pi times the radius squared equals, because those become 1, H. Okay, so if it's multiplying, all you have to do is divide. That's all you gotta end up doing. Alright, now if we look at the next one, surface area is area equals pi times R squared plus pi RL. We're solving for L. So this one's a bit trickier, okay, because we've got that plus in there. So we can't just divide things. First, we subtract pi R squared from both sides. So we get A minus pi R squared equals, because I can't combine those, that becomes 0. So we're left with pi RL. So divide by pi R. So the whole thing divide by pi R. Okay. Those become 1. That leaves us with L on the right side. Okay. Now, for this, you may want to say those can cancel out. And they kind of can, but not really. Because when we're subtracting with fractions, that's like A over pi times R minus pi R squared over divided by pi R. So on the right side, those could cancel 1, and we'd be left with just R, because I've got 2 R's on top. So it'd be A divided by pi R minus R is equal to L. So that one was a tricky one, wasn't it? Okay, but it's just following that step-by-step process. Now, if we take a look at 22. So this time it says the formula for calculating the number of calories burned while swimming at a moderate rate is C equals 2.9 times W times T, where C represents the number of calories burned, W represents your weight, and T represents the time you swim in hours. How can you use this formula to help you determine how long you should swim in order to burn a specific number of calories? So in other words, they're saying solve for the time. Okay, how can we rearrange this to get time as our result. So we divide by 2.9W. So basically you take the calories you want to burn, divide that by 2.9 times your weight. That's going to equal the time because those become ones. Okay, number 3, or 23 I think, right? The population of bacteria in a petri dish is 550 and increases according to the expression 550 times 3.4 to the 0.005 times t, where t is the number of hours. What effect would increasing the initial population of the bacteria have on the rate at which the number of bacteria increases? Okay, so in other words, if we make that higher, how is that going to affect this? Okay, it's not going to affect the rate, right? Because they're separate, they're being multiplied. So if I take that number and make it bigger, it's going to end up not changing how we're growing. We're still growing by the same rate, okay? Because that rate doesn't change if we switch this. So switching this will just mean, like graphically, or thinking about our equation or our starting number, we just start higher. Increasing will start us higher, but it'll still grow at the same rate. Okay? Whereas if we change t, as t changes, that's going to change. If we change this number, that's going to change how quick it grows. For example, if instead of changing the starting point, what if we change this, what it's grown by, this number, that would mean we start at the same place, but then instead we're starting to grow quicker or slower. Okay, that's how the two pieces are connected there. Alright, let's keep on trucking. So 24. A cable company has changed their way of charging customers. They will charge a flat fee for service and a separate amount per movie rented online. If C stands for money charged in a month and M stands for the number of movies rented, what is the equation you can get from this graph? So for our equation, remember, obviously we can see it's linear because it's a straight line. We're going to have y equals our start number, also called our y-intercept, plus our growth times x. Okay, in other words, y equals mx plus b. Okay, we just rewrote it as b plus mx, right? So our y-intercept and our slope. So y equals, where did we start? Well, look at the graph. We started at 80. So 80 plus, now how is it growing? Well, every time we go over, okay, that's over 1, we're going up 4. So for our slope, slope is y over x, so we'd go 4 over 1. Okay, that's how we do slope. So it'd be 4 over 1 times x. Now, can we simplify that? Yeah. Y equals 80 plus 4x, because that 1 really didn't do anything. Can we rearrange it? Yeah. Y equals 4x plus 80. And that's what our equation would look like. Okay. Now 25, same idea. This time it's an exponential, we can tell because of the curved graph, which would be y equals our start again, but this time times the growth to the x. In other words, y equals a times b to the x. B is what we multiply by. A is what we start as, our y-intercept. So I'd go y equals, then we look up where we starting. Okay, now this one's a little trickier to find. Normally it'll be multiple choice, so you'd be able to recognize. That looks about to be 13, a little over half. Okay, so we'd go y equals 13 where we start. Then how is it growing? Okay, well notice we're counting by months, so it's every 2 months. How are we increasing? The way to check this is try to look up those y values. So this would probably be close to 30. This would probably be close to like 110. This is exactly 325. So does that fit any sort of pattern for us? Okay, I'm not sure, but let's try it this way instead. Okay, we know what this point is, right? Normally it'll be multiple choice, so I think it'd be pretty clear what the number would be. But because it's not multiple choice, this point is 6, 325. We know what this is, right? Oh, and you guys probably won't be able to do this, will you? It'd be 13 times our number of growth to the x. Well, if y was 325 equals 13 times b to the 6th. So if we divide both sides by 13, we get 325 divided by 13 gives us 25. So it would be 25 equals b to the 6th. So normally we'd end up having, on the test you'll have multiple choice, so it'll be a lot easier to do. But what we would have to do is say what number times itself 6 times would equal 25, which ends up being like 1.71. Okay, I went and did that. So, our equation would be y equals 13 times 1.71 to the x. Tough for you guys to come up with, yeah, I know. Kind of screwed up on this question, didn't I? But the idea is that you find the starting, how it's growing, which usually, if you look at the way this is going, you could find it that way. Those numbers would be like 2, 4, 8. Then you could easily see, oh, we're doubling, we're timesing by 2, and that's what you'd put there. This one, not quite that easy to see, so that's why I had to help you out. But normally it'd be multiple choice, so you could kind of double check those and see what you had going. Alright, so last 3 problems, 26, 27, and 28, or all 26. Okay. A shoe store employee needs to decide how many shoes he can put on display. The store manager wants the number of boots on display to be at least twice as many as the number of sandals on display. The store employees represent this restriction as y is greater than 2x, where x is the number of sandals and y is the number of boots. Okay, so what are 2 possible solutions? In other words, what's a number of sandals to boots that I could do? Okay, but to write it as an ordered pair would be sandals, comma, boots. Okay, so let's say I wanted to put 10 sandals in. Well, how many boots would that be? 2 times 10 give me 20, so y has to be greater than or equal to 20. So it could be 1020, or it could be 1030, or 1040, okay? Because y can be bigger than 20, okay? So, what would be, that would work, or I could have chosen a different number. Maybe I wanted to start with 5. Okay, and then I'd go y equals 2 times 5, which would be 10. It actually should be greater than or equal to. So any number greater than or equal to, that one would work. There's 2 possible solutions. Okay, what about 2 non-solutions? Well, then I would just pick, let's say I wanted to figure out how many boots. So let's say I wanted 10 boots. Okay, so how many sandals would that be? Well, I'd go 10 is greater than or equal to 2x. Then I'd solve. So 5 is greater than or equal to x. So for sandals, it can be 5, or it'll have to be less. So maybe like 3. Okay, or actually that would work. So we want to go backwards and make it not work. So anything bigger than 5. So if I tried to do 10, that wouldn't work. 10 sandals and 10 boots would not be a solution to our inequality. Okay? And so I could just pick any of those that wouldn't work. So I could do another one. Let's say I wanted 8 pair of sandals. So y is greater than or equal to 2 times 8. 2 times 8 would give me 16, so y has to be greater than 16. So if it's less than 16, say it's 15, that wouldn't work. That wouldn't be a solution, because we wanted 2 non-solutions there. Alright, let's finish this out. Okay, let's look at the left side first. The population of Georgia is growing at a yearly rate of 1.3%. The current population is about 9,815,210 people. The population of North Carolina is growing at a yearly rate of 1.25%. North Carolina's current population is about 9,656,401 people. What is the equation that models Georgia's population growth? Okay, well, Georgia. So remember, percent growth, think of it as 100% plus the 1.3%. So it's really, their growth is really 1.013, okay? Because we have to do it as a decimal. Because when I add those percents, 101.3%. North Carolina would be 100% plus our growth, 1.25, so 101.25%. Or the growth would be 101.0125. Okay? So the equations here, we'd go y equals our start number, which was 9,815,210, times, because we're multiplying by a percentage, 1.013 to the x. For North Carolina, it would be y equals 9,600,000, oh, I don't want the commas in there, 656,401 times 1.0125 to the x. Okay, so that's what my equations, the start number and the growth. So then graphing those, okay, how am I going to make that look? So I'd make myself my x and my y. This would be the population. Okay, this would be yearly rate, so this would be year. Okay, so we've got to start pretty close to 9 million. Okay, now you may have noticed on these graphs over here that we did, they have this little squiggle line and then they start at 900. Okay, that squiggle line has to do with the fact that our graph is like taller than it really looks. Okay, it's kind of a shortcut way of jumping up without having to count. So let's say I started this at, let's see, we've got 9 million. So this was 9 million. Okay, then this would be 9,100,000, 9,300,000, 9,500,000. Okay, 700,000. Then 9 million, say, let's see, 7, 8, 9. So this would be 10 million. So 10,100,000. Okay, so we would start off with our first one, 9,800,000 would put us right about there. Okay, probably a little higher. The first one for North Carolina, the red, would be 9,656, so like right there. Okay, then it's growing by 1.013%. So I'd take, for Georgia, I'd take 9,815,210, and I would times that by 1.013. And I keep doing that year after year. So the first year, so here would be 1. So we would bump up to 9,942,000. So about right there. Okay, then year 2, we're already at 10. So it'd be right about there. At year 3, we'd go up a little higher. Okay, so it'd be going at this rate. Alright? So for red, if we did that one, 9,656,401 times 1.0125. Okay. We'd go up to 97 after the first year, right about there. Then we'd go up to 9,800,000. Right about there. Then 10, so it'd go up right there. So that one would be going up as well, and it'd look something like that. Okay. Now those are obviously difficult sometimes to graph very well, but that's what it would look like. Now if I were able to graph this and show you the picture. Maybe I'll do that at the end. Alright, now in the last 5 minutes, let's do the last problem. Minji injured her elbow during a varsity volleyball game. Her doctor has recommended physical therapy several times a week. Minji's parents want to plan for the potential cost of therapy over the course of a month. They pay $160 a month for insurance, and then another $20 fee each time they goes to the physical therapy. What equation models the total fees for physical therapy? What does the graph of the equation look like? So, let's think about this monthly. So, we've got a flat fee of $160 before she visits, right, for insurance. So this would be the number of visits. This would be the cost. So if she goes one time, we're adding 20, right? So it would be 180, go 2 times 200, 3 times 220, and so on. So the equation would be y equals 160 plus 20 times x. Okay, then we graph that, so we draw our axes, okay, the x and the y. Okay, this would be the visits, and this would be the cost. So we're starting at 160, so we may want to count by 20 every, no, let's count by 50. No, that's way too. If we go tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. See, that's not going to work quite. Let's go by 25s then. So 25, 50, 75, 100, 125, 150, 200, 250, and so on. So then we have our starting point. So we start at 160. So it'd be right above there. Okay. Then for every visit, so every time we go to the right, we're going to add 20 to that. So every time we go to the right, okay, then we get up to 180. So we add about 20. So every time we go to the right, we go up about 20, and we end up looking something like this. And that's what our line would look like. Okay? So that one was quite a bit easier than the exponential one. So, alright guys, that's pretty much it. Make sure that you are ready for this test. These type of problems are going to be very similar to the ones you see on the test. So, slightly complex and difficult, yes, but just give it your best effort. That's why I gave you this review to help out with that. And by the way, on this last question over here, this is, if I zoom out on a graph, that's what it'll look like. Okay, that's just scientific notation, so that was 10 million right here. Okay, because we started right below 10 million and see how they're growing. Okay? Alright, so there we go, guys.